Section 3.2, quadratic equations, functions, and zeros. Okay, section 3.2 is one of the biggest sections that we're going to go over. There's a lot of information in this section here, and a lot of different techniques for solving the types of equations that we're going to be solving. Okay, so let's first start off by defining a few things. So when I say a quadratic equation, I'm referring to ax squared plus bx plus c equals 0, or some kind of form or variation of that, where a, b, and c are real numbers, and x would be my variable. Okay, so something that has that x squared term, that would be the term with the largest exponent. It has to have a 2. Okay, so there's my quadratic equation. If I say a quadratic function, I'm talking about a function that can be written in that form. Okay, so it has an x squared again. There are other forms that we can talk about, but we're not worried about that at the moment. Okay, so here is a quadratic equation, quadratic functions. We know zeros mean to solve the equation when it's set equal to 0. And something else I want to talk about real quick. These are a couple of principles that are important for solving equations. Okay, so the first one we'll call the principle of zero products, or the zero product principle. And it says that if you have two things that multiply together that equal 0, the only way that that can happen is if one of those two things equals 0. Okay, so if a times b equals 0, then either a equals 0 or b equals 0. One of those has to equal 0 in order for the product to equal 0. Okay, so we're going to use that fact in a little bit. Okay, and then another principle called the square root principle. And the square root principle says that if you have some unknown squared is equal to some number, then the unknown, the variable, equals positive and negative square root of whatever the thing was equal to. Okay, we see that all the time, right? If you had x squared equals 4, well then x could be 2, right? Because 2 squared is 4. X could be negative 2, because negative 2 squared is 4. Okay, both of those are the square root of 4, and one's positive and one's negative. Okay, so that's called the square root principle. Now let's put these to use. Example 1. Let's solve the equation 2x plus 3 times 5x minus 2 equals 0. Okay, I'm going to start off with this one because it's a direct application, or we need to use the the product principle, zero product principle, because I can clearly see here that something times something equals 0, right? And so from that, I know that 2x plus 3 has to equal 0, or 5x minus 2 has to equal 0. That gives me two possibilities, two simple equations that I know how to solve. If I solve the left one, I would subtract 3 from both sides first to get 2x equals negative 3. And then I would divide both sides by 2 to get that x is negative 3 over 2. That is a solution. If I plugged in negative 3 over 2, this right here would turn into 0, and so it would be 0 times some number, which would have to equal 0. Okay, what about 5x minus 2 equals 0? Well, add 2 to both sides. 0 plus 2 is 2. Divide both sides by 5, and I get 2/5. So, if I plug in 2/5, this one will equal 0. This one would be some number. 0, or some number times 0, of course, will equal 0, right? So, both of these solutions force one of the sets of parentheses to equal 0. And of course, by doing that, you have found the solution to the equation. Okay, so of course they're not always given to us that way, right? sometimes you're going to have to actually work them out a little bit. So let's go on to example 2. Here we're given 10x squared minus 16x plus 6 equals 0. And I want to solve that equation. Okay, well, I need to factor this if I can, write it as a product where it's something times something else equals 0. If I do that, then I can do what I did in the last problem. Okay, but the trick is getting to that point. So the first thing I'm going to notice is I might be able to make my life a little bit easier if I recognize that these are all divisible by 2. If I divide them all by 2, I get a slightly easier equation to deal with. And more importantly, this new equation has the same set of solutions as the original. Okay, so they actually have the same solutions. So I can actually just solve this one. Okay, I need to factor that. I'm going to just do some trial and error real quick. So I know I have to have a 5x and an x because they have to multiply together to be 5x squared. And I know I need to have a 1 and a 3 because they have to multiply together to be 3. Now, since it has to be a positive 3, they can either both be positive. If that's the case, if I distribute 1x and 15x, if I add those together, that gives me 16x, which is no good. Okay, I need to equal that middle term. So that didn't work. Let's see if I can maybe try something else. Instead of a 1 and 3, maybe I can try 3 and 1. Okay, 3x, 5x. If I added those together, I'd get positive 8x. I need it to be a negative 8x, but I'm getting closer. Okay, they need to multiply together to be positive 3. Well, instead of multiplying by positive, or having positive 3 and positive 1, I'm actually going to just change those to negatives. All right, I'm just trying things, right? Trial and error. Just trying things until I find something that works. Okay, if I multiply those, I get negative 3x. If I multiply those, I get negative 5x. If I add them together, I get negative 8x. So far, so good. And negative 3 times negative 1 is a positive 3. So cool, we have factored it. All right, so now, what do I do from here? Okay, well, I set them, oops, I'm pushing buttons again. I set them individually equal to 0 because there's my first one. There's my second one. Let's solve them both. And add 1 to both sides, so I get 3/5 and 1. Do another one. 2x squared minus 20 equals 0. Okay, this is a quadratic, although it's kind of missing that middle term. That's okay. It still has x squared as the highest exponent variable. So what I'm going to do with that, I'm going to divide everything by 2, make this look a little nicer. Got to divide everything by 2 to make this work. Okay, now x squared minus 10 equals 0. I could factor that if I want to. It's kind of going to look a little ugly, but I could. But remember, we've been using the zero product principle. We could also use the principle of square roots. Okay, in other words, if we can write, just to remind you, if x squared equals a number, call it k, then x equals the positive and the negative version of the square root of that number. Okay, that is the square root principle. Okay, so I'm going to write this that way. I'm going to add 10 to both sides, so that way it fits that form. Because then I can jump straight to the answer. X equals positive square root of 10, and x equals negative square root of 10. I can't simplify that any further, so that's the solution. Example 4, 4x squared plus 12 equals 0. I see 3 terms that are divisible by 4, so I'll divide everything by 4 to make this look nicer. And it looks like I'm setting up another one of those square root principle type problems. And sure, I am. I'm missing that middle term, right? I have x squared and I have the constant, but I'm missing that middle term. So if that's the case, then just write it as x squared equals whatever. Subtract 3 from both sides. X squared equals -3. And so square root principle applies again. X equals the square root of -3. Ooh, what should I do with that? Oh yeah, it's -3 times I. Or square root of 3 times I. And negative of the same thing. Because again, remember, you get the positive and negative square root of -3. Of course, the negative comes onto the outside as an I. And remember, you have a positive and a negative answer. Example 5. 3t cubed plus 2t equals 5t squared. Okay, this does not look like a quadratic on the surface, but quadratics do come into play here. So I'm going to go ahead and get everything onto the same side of the equal sign by subtracting away 5t squared. It equals 0. Now I'm going to look for a common factor. And I see that they all have t in common. So I can factor out a common factor of t. Okay, I did not do like on those other problems and go and start dividing everything by t, right? Just to try to cancel it out. I can't cancel out a variable that way. Okay, keep that in mind. You can't cancel out the variable that way because you don't know what that number is. We don't know what t happens to be. If t is, let's say, 0, well then you're breaking all kind of rules trying to solve this equation. Okay, it can't divide by 0. And so if you're breaking the rules trying to solve it, you're going to get some kind of results that are probably not accurate. Okay, so we can't just divide by t because we don't know what t is. Okay, so now this looks promising. 3t squared minus 5t plus 2 can probably be factored. T stays the same. And we'll do like we did a few minutes ago with the trial and error. We know that the first term in each set of parentheses has to multiply together. They have to multiply together to be 3t squared. We know that the last two have to multiply together to be 2. And we know that they have to be the same sign but add up to be negative. This tells me same sign. This tells me they have to be negative. So minus, minus. Let's test it out. Negative t. Negative 6t. Those add up together to be negative 7t. That's not what I want. So let me switch around my 2 and my 1. Negative 2t, negative 3t, they add up together to be negative 5t. That's the middle term. Okay, I have it all factored. Now, I have 3 terms set equal to 0 that are multiplied together that equal 0. Now, the difference here, though, or not the difference, there is no difference. It's the same rule, okay? Even if it's 3 things that multiply together and equal 0, then one of the 3 has to equal 0. Okay, so we just set it equal to 0. Same thing is true. So the first term could equal 0. The second one could equal 0. The third one could equal 0. That first one is solved already. Don't have to solve that one. Second one, add 2 to both sides. And then divide both sides by 3. Add 1 to both sides. Okay, so those are my 3 solutions: 0, 2/3, and 1. All right. So those are the straightforward ways of solving these quadratics where factoring comes into play. Okay, you can factor on all of these, or use the square root principle or zero product principle, something like that. Okay, it all just depends. Let's talk about another method. Okay, I want to go over 3 methods. That was the first one. The second one is called completing the square. So I will demonstrate that. And completing the square leads to a third method that you probably have learned before. Okay, so completing the square is this strange procedure. And let's talk about it. Okay, so x squared plus 8x equals negative 15. Now this is actually in the right form. Okay, to do the completing the square method, you have to make sure that this is an understood 1 here, no numbers except for 1, and the variables are on the left side with x squared and x, and on the right side you have your constant. Okay, so this is set up just right. Okay, so the trick to completing the square, you take the number in the middle, this is a positive 8, you divide it by 2, that gives you 4, and then you square it, that's 16. And then you add that number to both sides. So I add 16 to both sides. X squared plus 8x plus 16 equals negative 15 plus 16, which is 1. So x squared plus 8x plus 16, I can factor that. Okay, you may recognize that's a perfect square. That's x plus 4 times x plus 4. It will always be x plus whatever number this happens to be in here. Okay, that's the whole purpose of doing that plus 16 on both sides. So x plus 4 times x plus 4 is the same thing, so I'll write that as x plus 4 squared equals 1. Now I can use the square root principle, right? Something squared equals 1. So that something squared could equal the square root of 1, which is just 1, or that something squared could equal the square root of negative square root of, or equals negative the square root of 1, so negative 1. Right? This thing is being squared, so that thing could equal the square root of 1 or negative the square root of 1. Alright, so subtract 4 from both sides, I get negative 3. Subtract 4 from both sides, I get negative 5. So negative 5 and negative 3 are the solutions using the completing the square method. I would have gotten the same thing had I factored this, by the way, right? If I decided to jump to that. X squared plus 8x plus 15 equals 0. This would factor as x plus 3x plus 5. If I set those individually equal to 0, I would get x plus 3 equals 0, which is negative 3. X plus 5 equals 0, which is negative 5, right? So they actually both work just fine. It just depends on whatever one works better at that moment. Let's do another one. Let's solve x squared is equal to 22 plus 10x. Okay, remember what I said. You have to get the x's, the variables, on the left side, and you need to get the constants on the right side. So the constant's already on the right. It's 22. Okay, 22. So I just need to get rid of this 10x here. So I'll subtract 10x from both sides. X squared minus 10x equals 22. Okay, now I have to do that weird little trick, right, where you take this number here, negative 10. Let me put that a little lower. Negative 10 divided by 2, that's negative 5. Square it, that's 25. I'm going to add 25 to both sides. Uh, 22 plus 25 is 47. Okay, so x squared minus 10x plus 25 equals 47. And then I said earlier that this will always factor to be x, and then whatever this happens to be inside here. In this case, it's a negative 5. Now I can use the square root principle. Square root of both sides, I get positive and negative square root of 47. Okay, square root of 47, I can't actually break that down, so it's going to stay like that. But I'll add 5 to both sides to finish this problem. So x equals 5 plus the square root of 47, or x equals 5 minus the square root of 47. Okay, and this brings up the third method. Okay, so let's actually talk about the third method. I won't even say what it's called yet. Let's talk about how we would handle this next problem here. Okay, so ax squared plus bx plus c equals 0. Let's say this is the equation I'm trying to solve. I want to use the completing the square method to do it. I can't factor it because I don't know what these numbers are, but at least I know the procedure for completing the square. Remember, we did say that the number in front of x squared had to be a 1, okay, and the constant had to be on the other side of the equal sign. So those are two things I need to take care of up front. So to make this turn into an a, or sorry, turn into a 1, I will divide everything by a. That gives me 1x squared plus b over ax plus c over a equals 0. Then I subtract c over a from both sides because it's a constant, right? If it's not x or not a variable in general, it is not a constant. A, B, C, they're all expected to be real numbers. Okay. So this equation's good. Now I do the completing the square trick where I take this middle b over a, divide it by 2. That's just sticking a 2 in the denominator. That's how you divide a fraction by 2. You just multiply the denominator by 2. And then square it. So that's b squared over 4a squared. Add that to both sides. Okay, negative c over a, well, I'm adding b squared over 4a squared to both sides. Okay, a couple things I want to take care of now. I know this denominator and this denominator are not the same. I want to actually make them the same. So I'm going to multiply c over a by 4a over 4a, right? I'm just multiplying it by 1. So I'm not changing the value, just changing how it looks. Okay, so on the right side, I have b squared minus 4a squared minus c over 4a squared. Those are common denominators, so I could put those together actually. B squared minus 4ac, I'm not sure if I wrote that a second ago, over 4a squared. On the left side, remember, we added this thing to both sides so that it would factor in a particular way. And it does, x plus whatever I got here, b over 2a. So x plus b over 2a squared equals b squared minus 4ac over 4a squared. I use the square root principle. Remember, that says I can take the square root of both sides, and that will give me a positive and a negative square root of b squared minus 4ac over 4a squared. Keeping in mind that I can just take the square root, and instead of putting it over the whole thing, I can do it over the top and the bottom separately. So that's positive and negative square root of b squared minus 4ac over 2a, because the square root of 4 is 2, and the square root of a squared is a. So I'm able to actually just rewrite this with a fraction of 2a. And that's good because that has a common denominator with this one here. So when I subtract b over 2a from both sides to get x by itself, they have common denominators, so I can actually put them together. So I'll subtract b over 2a from both sides. And I'm left with this. And voila, this is our infamous quadratic formula. Okay, and you see where this equation comes from, right? This formula comes from. This is the actual work behind it. This is what justifies this as solutions, right? You can use the quadratic formula to get solutions because of the completing the square method. All right, so anyway, you get the same answer no matter what. So quadratic formula or completing the square will let you solve any quadratic equation. Factoring will only allow you to solve the nice, well-behaved equations, quadratic equations. Okay, let's go on then to using the quadratic formula. Let's solve 2y squared minus 3y minus 2 equals 0. Now this may be factorable, but I'm going to jump straight to the quadratic formula. I know I'm using a y instead of an x, but it's okay. Negative b plus or minus square root b squared, I need to put that in parentheses, b squared minus 4ac over 2a. Okay, a in this case is 2, b in this case is negative 3, and c is negative 2. So negative b plus or minus the square root of b squared minus 4ac over 2a. Simplify this one piece at a time. Minus a negative becomes positive, so it's positive 3 plus or minus. Negative 3 squared is 9. 4 times 2 is 8, or negative 8, right? Negative 4 times 2 is negative 8. Negative 8 times negative 2 is a positive 16. 2 times 2 is 4. 9 plus 16 is 25. Oh, wait, we know the square root of 25. It's 5. Okay, can break this up into 2. Y equals 3 plus 5 over 4, and y equals 3 minus 5 over 4. The one on the left, 3 plus 5 is 8. 8 divided by 4 is 2. On the right, 3 minus 5 is negative 2. Negative 2 over 4 is negative 1/2. So there we go. Quadratic formula got me to the solutions without having to factor it. Although this one would have factored just fine. Let's see if I can fit another one here. Let's solve 5x squared plus 2 equals x. If I want to use the quadratic formula, I need to take care of this x and move it onto that side. So I'll do that. Subtract x from both sides. Now I will identify a, b, and c. A is 5, b is negative 1, c is 2. Negative b plus or minus square root b squared minus 4ac all over 2a. Two negatives make it a positive. 1 squared is 1. 4 times 5 is 20. 20 times 2 is 40. Okay, so that's 1 minus 40, which is negative 39. Over 10. 2 times 5 is 10. Okay, I need to take care of that negative under the square root. Remember, that just comes out as an I. So it's 1, positive and negative, I times the square root of 39 over 10. All right. Last thing we need to talk about, it's called the discriminant. And that's a way you can determine if your equation, your quadratic, has one solution, two solutions, or none. Those are your three options. One solution, two solutions, or none. Well, the discriminant is the part that's under the square root in the quadratic formula. If this thing is equal to 0, then you have one real solution. If b squared minus 4ac is greater than 0, then you're going to have two different real solutions. And if the part under the square root is negative, then you have two imaginary solutions. Okay, so let's try that out. And actually I have two more examples to go over. All right, example 10, 5t squared minus 4t equals 11. Okay, in order to do this, I need to get 11 canceled out. I need to get this thing set equal to 0. So I'll subtract 11 from both sides. Okay, identify A, B, and C. A is 5. B is negative 4. C is negative 11. Plug them into the discriminant, b squared minus 4ac. Okay, because that's what we're asked to find here. Not to solve it, but to find how many solutions or what kind of solutions. So negative 4 squared minus 4 times 5 times negative 11. Right, these two minus and negative make it a plus. 4 times 5 is 20 times 11. It's 220. If I add those together, I get 236, which we know is bigger than 0. So if it's bigger than 0, then we have two different real solutions. Okay, and I just stole that from up here. Okay, last question. Let's solve this equation here. Now, this does not look like a quadratic. Technically, it's not, right? But we can treat it like a quadratic. First of all, let's get 4x squared canceled out, subtracted from both sides. X to the 4th minus 4x squared plus 3 is equal to 0. Okay, and then from here, I want to look at this a little differently. Let's just pretend for a second that x squared is y. Okay, I'm just calling it y. Doesn't really matter. Then I can think about this as a quadratic. This just becomes y squared minus 4y plus 3 equals 0. Right? Think about it. If y is x squared, that means y squared is x squared squared, which is x to the 4th. It's just a fancy way to, get back to the original here. This is 4y, which is 4x squared. Oh, you see, it's the same thing, right? It's the same thing. So I can think about it like that because now I can just solve it. I'm thinking I can factor this. Y minus 3, y minus 1. Yep, that'll work. If I set them both equal to 0, I get 3 and 1. Okay, so y equals 3 and y equals 1. But what is y? Y is x squared. So what have I found? X squared equals 3. X squared equals 1. Use the square root principle to solve these. Square root of both sides positive and negative square root of 3, square root of both sides, positive and negative square root of 1, which is just 1. So positive and negative square root of 3, positive and negative 1. Okay, so that's the very large section 3.2. Hopefully that's not the worst that you've ever seen. Okay, so quadratics, quadratic functions, quadratic equations. We talked about factoring, completing the square, the quadratic formula, where the quadratic formula comes from, and writing equations that look like this as a quadratic so you can solve it. Okay, so quadratic is now in our toolkit as we move on to the remainder of these functions.